Next up, we have Sean McGinn, who will be sharing with us from Melbourne. Buildings digital leader for Australasia, Sean's a structural engineer with a passion for working collaboratively with leading architects and contractors to realise large, complex and often high-profile projects globally. And in fact, Sean, I believe, was working on the MX3 bridge that John mentioned earlier. A particular focus for Sean, and something I know he's going to draw out today, is finding opportunities to add real value for projects for both clients and contractors by using new and emerging technologies. Sean, take it away.
Thank you very much, Bree, for that lovely introduction. I'm Sean. Welcome, everyone. Good evening, morning, afternoon, wherever you are. As Bree mentioned, I'm a practicing structural engineer and currently leading the digital drive for our buildings business in Australasia. So my talk is entitled Skills Shortages and Augmented Humans in Construction, intimating that the latter is potentially a means to help assist with the former. So over the next 5 minutes or so, I'll try to put the skills shortage issue in context here and illustrate a couple of exemplar solutions via two of my very favourite projects. Now, Australia is often touted as having a skills shortage in engineering, so let's just unpack that a little bit. This is a summary from the Government Department of Employment, who keep a pretty close eye on such things. And as you can see, the high-level summary, at least, is that there is no shortage for engineering professions. And at an average, there are 16 qualified applicants for every position. However, you dig into this very slightly, a staggering 87% of qualified applicants are either considered unsuitable due to either a lack of relevant experience or insufficient technical skills. And that problem becomes more acute when you're looking at senior roles requiring extensive experience. Now, as a young developing island nation, which we still very much are, we've historically relied on importing talent to help supplement our workforce. And of course, in this current climate, that tap has been turned abruptly off. Now, these stats, of course, just relate to the current skills in the construction industry. Emerging and future specialist skills in blue shown here are just a subset of those which are really establishing themselves in our industry at present, though the number of people who can effectively deploy them is extremely limited. So the next couple of a few slides will show two of my favourite projects and how technology applied by us as designers can be productively used in real world to benefit projects and utilise the skills that are available. Now, Project Q was aimed squarely at providing a much higher standard of accommodation for remote Indigenous communities. This is the current paradigm, which is clearly far from ideal. And this is a potential solution. Now, this is a deceptively high-tech, modular, flat-packed, off-grid, carbon-neutral dwelling, including fixtures and all the furniture. And this arrives in 6 containers and can be erected by 6 people in just 6 days with no specialist lifting equipment. But critically, it's the local communities who are involved in the design development, and the intention is fully for them to build their own houses. And this is where the technology comes in. So Dennis and John here are 2 Tiwi Islanders with no previous construction experience at all. And by replacing an instruction manual with a virtual reality experience, they were able to self-teach how to put this house together. Now, this is what they're actually looking at. I'll just fast forward to part of this. It's really a step-by-step process in which they could play, pause, rewind, walk around the model in detail to fully understand the process at a granular level of detail. And this proved to be a really great success, and the experience and skills that John and Dennis developed through this process then formed a positive feedback loop that was used then by us as designers to refine the next iteration of the design. The next project is a very recent one in Brisbane and led by my colleague Joe Thiang, who's currently on assignment in Los Angeles actually, and doing an amazing digital fabrication work there, which I hope to be able to show you again very shortly as well in the near future. So the challenge here, it's a premier mixed-use high-rise development, residential accommodation above, commercial below, and with a very complex reinforced concrete transfer deck in between the two. Now, this is the usual way that the design of such a structural element is communicated in our industry, and has been largely unchanged in probably more than a century now, when we had no option but to put black marks on white paper. And at best, it's a very abstract representation of what is actually going to be built. And even myself, with many years of experience in the industry, would have to look at this for quite a long time to fully appreciate the level of complexity embedded in this. And that complexity is going to become apparent pretty shortly. So the contractor, in this case it was ProBuild, saw the opportunity to de-risk the construction and engaged us to fully model all of the reinforcement in this transfer deck in 4D. And this opened up an entirely new dialogue between the engineer and the contractor, combining the skills of both to explore construction sequences, pour breaks and iron out all of the potential junctions and complexities long before the actual build itself. And as the model itself exists in 3D, we experimented with porting this to a virtual reality platform. And this proved really effective and engaging. So the guy in the bottom right in the high vis is actually a steel reinforcement fixer. And we never get to talk to this sort of person normally during the stages of design. Yet his input was found to be absolutely invaluable in optimizing and rationalizing this structure. Now this video, of which I'll play just a little snippet, will give you an idea of some of that complexity. Each of those colors represents different pores. And you can get an appreciation for how some of that complexity was resolved in 4D, pore by pore, detail by detail. And the same data was then recycled again, this time on site, and this time using an augmented reality platform in which an accurate image of subsequent construction stages could be projected in situ onto the build itself. So this greatly improves both communication and coordination on site. And this proved to be a real game changer, vastly reducing RFIs. And we used this fairly new device, the Trimble Site Vision device, which the chap in the bottom right-hand corner is using in a high vis. We now have one of these in every one of our offices in Australasia for exactly this reason, because it makes such a big difference. And we see this as a real game changer potentially. Now these projects both illustrate actually the benefits of digital fabrication and how technology can be used to overcome some of the skills shortages. And furthermore, just creating an environment, which is often a virtual one, in fact, in which both designers and builders can collaborate, can lead to much, much better outcomes for the project, better and more efficient use of materials and available skills, and also simpler and safer to build. Now, we're super keen to do much more of this end-to-end delivery, just taking the digital assets originating in the design and running it right the way through construction and even post-occupancy. So if you are interested in collaborating, taking that journey with us, then please get in touch. Thank you very much indeed. I'll leave you with this quote.
Thank you, Sean. That was really fascinating and draws out the connection that we've been discussing between the contractor and the designer and the importance of having that input throughout the process, particularly in those initial stages.